All right, so yesterday we talked about rationalizing the denominators. You guys were given that quizzes to be able to work on last night as well, to help you practice that rationalizing. Remember, when we have a denominator that cannot be simplified, I'll collect it in a little bit. When we have a denominator that cannot be simplified to a perfect square, and we still have a radical in the denominator, then that means that you have to rationalize it. Okay, so all you're doing is multiplying both numerator and denominator by whatever the denominator's value was. Okay, yesterday we only practiced doing some examples where it was numerical terms. Today we're going to practice a little bit with variable terms, and then we're going to move on to our multiplication as well. Okay, so if we're looking at problems 4 and 5, and I think that's it for our rationalizing, right? Yeah. So for problems 4 and 5, we're dealing where we have not just a numerical value, but we also have a variable value within the denominator. So for here, with problem 4, square root of 13 over 50x. 50 is not a perfect square. X is not a perfect square. You cannot simplify 50 with that 13 either. Yeah. All right, let's get back to it. So here, again, like I was saying, 13 and 50, you cannot simplify those at all. So what we have to do is go ahead and rationalize the denominator. So we're going to multiply both the numerator and the denominator by the square root of 50x. You're going to multiply by 50x, not just the number, but also the variable as well. Okay, so when we multiply both numerator and denominator by 50x, it basically means that we're multiplying 13 times 50 and then keeping the x at the end. 13 times 50 is going to come out to 650. And yes, I know you're dealing with some larger numbers here. You get 650x over, now if we do 50x times 50x, 50 times 50 is going to give us 2,500. And then x times x is going to give us x to the second power. We already know that, right? We add our exponents. But do I need to really do all of that? If you guys already know that the whole point, the whole purpose of rationalizing the denominator is so that you can just get rid of the radical sign, what is it going to simplify to once you take the square root? It's just going to simplify to what the denominator was, the 50x. Take a look at all of these. It was pointed out by somebody yesterday. I forget who. I think was it Alex? Didn't you point it out? I think so. When we rationalize the denominator by multiplying by square root of 12 times square root of 12, we just get 12 at the end. When we rationalize this denominator and did square root of 2 times square root of 2, we just get 2 at the end without the square root. Square root of 7 times square root of 7, you just get 7 at the end. So if I do square root of 50x times square root of 50x, at the end, I'm just going to get, what? 50x. Just going to get that 50x. So I don't even need to worry about multiplying the denominator by the denominator again if I know that eventually I'm going to take the square root of it and it's just going to become what the denominator was without the radical. So now the only thing I have to focus on is that numerator. So 650, we want to break this down. Now, you're not going to typically get numbers this big. We're not going to throw something like that at you on the test. We're not going to throw something that big at you on an assignment. This is just for an example purpose. But 650 can be broken down into the square root of 25, which is a perfect square. And what we're remaining with is the square root of 26x, because we already know x was not perfect. It's just a single value of x. And then all of this is going to be over that 50x. And now we just need to take that square root of 25. Square root of 25 is going to give us 5. And then you have square root of 26x. And the whole thing is over 50x. Now again, I tell you guys, the reason I do things in color is so it's a little bit easier for you to see what maps to what. Can I simplify these x's? No. I have them in different colors for a reason. The one that's in green is because it's still inside that square root. The one that's in pink, it's no longer inside the square root. So they can't be simplified. Okay? Can I simplify the 26 and the 50? No. Because again, 26 is inside a square root. That's actually not a 26. That value is not actually a 26 at all. It's a 5 point something. Okay? So you cannot simplify 26 and 50, but can I simplify 50 and the 5? Yes. They are both outside of a radical. They are not inside of a square root. So you can simplify the 5 and the 50. What are they both divisible by? 5, right? Remember your divisibility rules. If it ends in a 5 or a 0, it's divisible by 5. So they're both divisible by 5, which means my final answer, 5 divided by 5, is going to give me a 1. Do I have to put the 1? No. It's a coefficient of a 1. You don't have to put it. So it's just going to be square root of 26x. And then 50 divided by 5 is going to give me what? 10. But don't forget your x at the end. Okay? And there's your final answer. Square root of 26x over 10x. I want you guys to do number 5 on your own. All right, let's go ahead and take a look at this one. So for here, for problem number 5, there's actually 2 ways I'm going to show you guys how to solve it, especially because you don't want to be dealing with such large numbers sometimes. So for most of you, you probably were focusing on actually just multiplying by the square root of 48x and the square root of 48x, which is easy for the bottom because we automatically know that once it's simplified, it's just going to be this 48x. That part we know. But when we multiply 32 times 48, that's going to give us a really large number. We're going to be dealing with a number in the thousands, right? 1,536x. And when you get it that big, that's kind of hard to see how you can break that up. The largest perfect square that can actually go into 1,536 is going to be the square root of 256. And then what you're left with is the square root of 6x. Okay, and the whole thing is over the already simplified 48x. Okay, when you take the square root of 256, you're going to get 16. So you have 16 square root of 6x over 48x. And then you're going to have to simplify, right? You're going to have to go, okay, well, I know these are both divisible by 16. 48 can be divided by 16. And our final answer is just going to be square root of 6x over 3x. But there is another way that you could go about it if you're not wanting to deal with such large multiplications, such large products. What you could do instead is you could simplify first. There's nothing wrong with simplifying first if you're able to. With problem 4, we're not able to simplify, right? 13 and 50 have nothing in common. You wouldn't have been able to simplify that at all. But the square root of 32 over 48x, the 32 and the 48 actually are both divisible by 16. If I divide both of them by 16, then I'm dealing with smaller numbers here. Okay, once I divide them, I'm going to get square root of 2 on the top, and then the square root of 3x on the bottom. That's a lot nicer to deal with, a lot easier to handle. Okay, all I would have to do then is rationalize the denominator. Multiply both the numerator by 3x and the denominator by 3x. What's 2 times 3x going to give us? 6x. So I get square root of 6x. And then, of course, square root of 3x times square root of 3x is just going to give us 3x, right? Square root of 9, x squared, but that would simplify to 3x, right? Same square root times the same square root means you just get whatever the radicand was. Remove the radical, you're left with just the radicand, and you're done. Look at how they're the same answers. So which one do you think is easier? Simplifying ahead of time or simplifying at the end? Simplifying ahead of time. When you simplify ahead of time, you're working with smaller numbers. You're less likely to make a mistake. It is up to you, though, how you decide to work with it. Okay? We're going to pause for just a second. God bless you. Pause for just a second, and I'm going to have you open up your quizzes. All right, so instead of quizzes, we're going to do a quick check on paper. Make sure that you've got your paper down. Make sure you give yourself enough space to show your work as well, so that way you can see if you've made a mistake anywhere. I'm just going to give a couple of examples, some of them with just numbers and some of them with variables. So for problem number 1, we're going to do the square root of 7 over 15. Problem number 2, let's try this one out. Let's see how you do with this one. 4 square root of 2 over 3 square root of 5. I want to see how you guys do with that. Problem 3, the square root of x over 7y. And then problem number 4, we're going to do the square root of 3 over 5x. So we're just going to have those 4 questions that you're going to do a quick check on. So again, number 1 was the square root of 7 over 15. You don't need your computer. We're doing it on paper. Square root of 7 over 15. Number 2 is 4 square roots of 2 over 3 square roots of 5. Number 3 is square root of x over 7y. And then number 4 is square root of 3 over 5x. All right, let's go ahead and go over this. For problem number 1, we want to go ahead and multiply both of these by the square root of 15, because you cannot simplify at all. Right, 7 and 15, you can't simplify them, so we're going to go ahead and multiply by the square root of 15. Remember, that just comes out to 7 times 15 inside that square root, which becomes the square root of 105. And because of the fact that we're doing a square root of 15 times square root of 15, that's just going to come out to 15 at the end. Okay, you don't have to worry about doing 15 times 15, which is 225, and then taking the square root of 225 to get 15. You already know it. So there should be your answer for problem number 1. Everybody okay so far? Okay, let's take a look at problem number 2. This one, I want to see how you guys did. What do you have to multiply the numerator and denominator by? Alex? Okay, good. We don't have to multiply by the 3, do we? Because is the 3 inside the radical? No. The 3 is not inside the radical. You only have to rationalize your denominator, meaning you only have to multiply by the radical, not the coefficient of the radical. So all you're going to be multiplying both by is the square root of 5. Now, these numbers, these 4 over the 3, those don't get affected at all. They're just going to stay 4 over 3. And I'm going to put little multiplication signs in behind them so that I know that whatever comes next, if there happens to be a coefficient, I'm going to multiply by it. What's 2 times 5? 10. Is that perfect or non-perfect? Non-perfect. So we're going to go ahead and put square root of 10. And then square root of 5 times square root of 5 is just 5. Okay, it's 25, square root of 25, but then square root of 25 is 5. So I can now multiply. I can multiply 3 and 5 together. I can multiply that 3 and the 5 together because they are not inside of a radical. I cannot simplify square root of 10 because it is as simplified as it's going to get. So this is going to be 4 square root of 10 over 15, and that's it. I'm done. That's as finalized as it's going to get. Okay, let's take a look at problem number 3. We have square root of x over 7y. Okay, nothing that we can simplify here. X and y are different variables. You cannot simplify them, so you're just going to multiply both the numerator and the denominator by the square root of 7y. Multiply numerator and denominator by square root of 7y. What is x times 7y going to give us? 7xy. Good. So we get square root of 7xy. Okay, so when I do square root of 7y times square root of 7y, I'm keeping the 7y and getting rid of the radical. So your final answer is right here. Square root of 7xy over 7y. Okay. Number 4. We have the square root of 3 over 5x. Can we simplify? Yes or no? No, can't simplify, so we're just going to multiply. What are we going to multiply both by? Not just 5x, square root of 5x. You're going to multiply by the square root of 5x, or radical 5x. Okay, what's the square root of 3 times square root of 5x going to give us? Square root of 15x. Good. And then what is the square root of 5x times the square root of 5x? 5x. That's it. It's not too hard, right? Not too bad. Okay, let's get back onto the notes. We're going to get out of division. Okay, get out of the division. We're going to go straight into multiplication now. So multiplication should be simple because you've already practiced multiplication before, right? You just showed me that you know square root of 7 times square root of 15 is just multiplying 7 and 15 together and keeping it under one square root house. Okay, same thing here. If we did square root of x times square root of 7y, we're just going to get the square root of 7xy, all of it under one house. So it's no different here. Square root of 3 times the square root of 6 means that you're just going to have one radical. You're going to have just one radical sign. And you're just multiplying 3 times 6 underneath that radical. What's 3 times 6? 18. So we get square root of 18. Square root of 18 is not a perfect square, but can I break it up into a perfect square? Yes. We can break it apart into a perfect square and a non-perfect square. So we can do the square root of 9 and the square root of 2. What's the square root of 9? 3. So we're going to get 3 square root of 2. Go ahead and do number 2 on your own. All right, what's square root of 8 times square root of 6 going to equal? Square root of 48. Good. If we multiply these, all we're doing is taking 8 and multiplying it by 6. That gives us square root of 48. Can we simplify that? What perfect square goes into 48? 16. So we get square root of 16 times square root of 3. And then square root of 16 is going to equal 4. So we get 4 square root of 3. Okay, no different with variables. Variables, it's a similar concept here. Okay, we've got that 2 that's on the outside. That 2 is going to remain unaffected. All we're going to focus on multiplying here is our radicals. So square root of 8x times 4x. And another way to be able to look at that, guys, is that you're just multiplying your numbers with your numbers and your variables with your variables. So you're doing 8 times 4, and you're doing x times x. Okay, what's 8 times 4? 32. So we get 2 square root of 32. And then what's x times x? X squared. Good. X to the second power. Okay, now x to the second power, that is a perfect square, isn't it? X to the second power is a perfect square. What about 32? Is that perfect? What perfect square can go into it, though? 16. So we have square root of 16, square root of 2. And then, of course, we have this 2 in the front. Okay, what's the square root of 16? 4. So we have 2 times 4, and then what's the square root of x squared? X, and then we get square root of 2. Okay, and then we can still multiply. We can multiply 2 times 4x. What's 2 times 4x? 8x. So we get 8x square root of 2. And we're done. 8x square root of 2. Okay, go ahead and try number 4, 5, and 6 on your own. Try problems 4, 5, and 6 on your own. Alright, so for problem number 4, we have 3 square root of 2m times the square root of 14m. So again, we're going to focus on the 3 just being out on its own. What you're really going to be doing is multiplying the numbers with the numbers. So we're going to do 2 times 14, and we're going to do m times m. Okay, 2 times 14, that's going to come out to 28. So you get 3 square root of 28. And then m times m, that comes out to m to the second power. 28, you can go ahead and simplify it into a perfect square and a non-perfect square. What perfect square goes into 28? 4, very good. And then the non-perfect square is 7, because 4 times 7 is 28. Okay, and then m to the second power is a perfect square. Okay, so I have the 3 is already on the outside. Square root of 4 is going to come out to a 2. Square root of m squared is going to come out to m. And then we have square root of 7 on the inside. So the entire thing, when I multiply the 3 times the 2m, that becomes 6m square root of 7. 6m square root of 7. Okay, let's take a look at problem number 5. With problem number 5, you've got this 2 on the outside that you're multiplying with the numbers, which are 15 times 3, square root of 15 times 3, and then your variables, you got square root of x to the 4th times x. Okay, 15 times 3 is going to come out to 45. X to the 4th times x is going to come out to x to the 5th. So you have 2 square root of 45 square root of x to the 5th. Square root of 45 can be broken apart. You've got square root of 9 that can go into it, and square root of 5. Sorry, I forgot to put the square root symbol. So we've got square root of 9, square root of 5. And then x to the 5th, obviously, we can break that apart back again to square root of x to the 4th. Square root of x. Okay, that means that we're going to have 2 times. The square root of 9 is going to give us 3. The square root of x to the 4th gives us x to the 2nd. And then we're left with the square root of 5x inside of the radicals. Once we multiply these coefficients together, that leaves us with 6x squared square root of 5x. Okay, problem number 6. Here we've got 2 coefficients. So we're actually going to be doing 5 times 2 times, and then inside the radicals, we're going to have square root of 15 times 5 and square root of x to the 3rd times x to the 5th. 5 times 2 gives us 10. Square root of 15 times 5 gives us square root of 75. Square root of x to the 3rd times x to the 5th gives us x to the 8th. 10 remains on the outside. Square root of 75, we can split it up as square root of 25, square root of 3, and then square root of x to the 8th is a perfect square, so I'm going to change it to pink. Alright, what's the square root of 25? 5. What's the square root of x to the 8th? X to the 4th. And then we have square root of 3. Okay, now we need to just multiply. Multiply those coefficients together, the 10 times the 5. That's going to give you 50x to the 4th square root of 3. Okay, it's a lot. I know it's a lot. But is it at least starting to feel a little bit more mechanical, like easier to do a little? Okay. All right, let's go to the last one then. Yeah. Last page. More multiplication with radicals. This one should be pretty simple, I feel. I feel these are a lot easier to do or to manage through because they're squared. They're squared up values. So it's just like any kind of exponent. You distribute that exponent to both the coefficient and to the radical. You're distributing the coefficient to, or the exponent to the coefficient and to the radical. So what this winds up becoming is 2 to the second power and square root of 5 to the second power. Okay? What's 2 squared?
4.
4. What's the square root of 5 squared? 5. Think about it. Square root of 5 times square root of 5 is square root of 25, and square root of 25 is 5. So you just get 20. So with these ones, it's real simple because whenever you square a square root, those are inverse operations, guys. Let's take a look up here at the top. I'm going to write that down. Remember I told you guys before that a root is really just a exponent in fraction form. So square root of 5 is the same thing as saying 5 to the half power. So if I say square root of 5 and I'm wanting to square it, then that's the same thing as saying 5 to the half power, multiplying it by 2. And what's a half times 2? What's 1 over 2 times 2 over 1? 1. 5 to the first power, which is just 5. Okay, so the opposite of a root is the square. Square root and square are opposites of each other. They undo each other. They make it as if they never existed, and you're just left with the radicand. Okay, so let's take a look here. Same thing here. We have 6 square root of 7. The whole thing's being raised to the second power. I'm just going to take that second power and distribute it to both, which means I'm doing 6 squared, and then I'm doing square root of 7 squared. 6 squared is 36, and then the square root of 7 squared is just 7. And now I do 36 times 7, which is 252. Do number 3 and 4 real quickly on your own. Do 3 and 4 real quick on your own. I'm going to write it on here as well, so that way we can just keep going with it. All right, for problem number 3, what did you get? 125. Very good. What about for number 4? 32. Really quick and easy. Very, very simple. With problem number 5, it's the same exact concept, except now you're distributing it to not just the 6, but also to the x and to the square root. So we're doing times it to the 6, distribute it to the x, distribute it to the square root. So we have 6 squared, x squared, and then the square root of 3x squared. 6 squared is just 36. X squared is just x squared. And then square root of 3x squared is just 3x. So then here's the thing. You now have a number times a number and a variable times a variable. So we're just going to do 36 times 3 and x squared times x. That's going to give us 108 x to the third power. Okay. Do one more real quickly. We've got this 2. We're going to distribute it to the 3, and we're going to distribute it to the x to the third and to the square root of 2x. That means we've got 3 squared. We've got x to the 3 times 2 power, and then we've got square root of 2x that is now going to be squared. That's going to become 9x to the 6 times 2x. We're just going to multiply the numbers together, so we're going to focus on doing 9 times 2, which is 18. And then we're going to multiply x to the 6 times x. X to the 6 times x just gives us x to the 7th power. Okay, I'm going to do one example of this, and then you're going to do the other 3 on your own tonight as your practice, and I'll load these notes up as what they would look like. Tomorrow for Digital Day, you're going to have either IXL or Delta Math, or it might be a small combination of both. Okay, let me show you real quickly how to do this one. For problem number 7, all you're doing is you're just distributing. You're distributing the square root of 2 to the 5 and to the square root of 12. So you're doing 5 times square root of 2 plus the square root of 5 times the square root of 12. 5 square root of 2 just stays 5 square root of 2. And then 5 times 12 becomes the square root of, oh, I'm sorry, I just did square, oh, I messed up. That should be square root of 2, not square root of 5. So 2 times the 12 becomes 24. Okay, now we can go ahead and simplify this. 5 square root of 2 plus, this can become square root of 4 and square root of 6, which then becomes 5 square root of 2 plus 2 square root of 6, and that's your final answer. Okay, you're just distributing it, you're multiplying it. If it's not inside of a radical, it's just the coefficient in front. If it is inside a radical, you multiply the two numbers together. Okay, I'll show you the others tonight online. Oh yeah, turn in your quizzes. Just come over here and put it on the table.
But you get John.
You're dismissed. You can go. tell them they can come on in. Okay, because they're the same radical, you can go ahead and add those together.